Hey everybody, welcome to section 4.4, L'Hôpital's rule. It looks like it says hospital, but this is a silent H and a silent S, so it's L'Hôpital. Anyway, L'Hôpital's rule says, well, what if, for example, number 1, you're trying to find the limit, because this is all about limits. And this one's going to be the limit as x approaches 0. And suppose that we have cosine of x minus 1 over x. So of course you first want to try and just plug in a 0, but as you can see right there, that's going to cause trouble. The bottom is going to equal 0. Also, if you plug in 0 right here, cosine of 0 is 1, so that means that the top is 0 and the bottom is 0. So this part in red right here is actually important because if it was 7 divided by 0, you can't use L'Hôpital's rule. If it was 0 divided by 7, you can't use L'Hôpital's rule. It only works if, when you plug in this, it's 0 divided by 0, or as I'll show you pretty soon, it could also be infinity divided by infinity. Now, L'Hôpital's rule goes like this. So this is going to 0, and this is going to 0. But how fast are they going? So it's like a race. They're both trying to get to 0, but who's going faster? And fast means derivative. How fast is it changing? So we're going to use L'Hôpital's rule. And what it basically says is, take the derivative of this, take the derivative of this. And you do that separately, not like the quotient rule, just what's the derivative on the top, what's the derivative on the bottom. And whenever you use L'Hôpital's rule, please write a little thing like this indicating in this step I'm using L'Hôpital's rule. So on the top you take the derivative of cosine, that's going to be negative sine of x. And of course derivative of that will be 0. On the bottom, take the derivative of x, which is just a 1. Now we can plug in 0, and there is no more division by 0. So this is just going to be negative, what's sine of 0 divided by 1? And sine of 0 is 0, so the answer is 0. And I should be able to graph that and verify that I got it right. So graph cosine of x minus 1 gets divided by x. And then I can change the window to be fairly close to 0. So I'm going to go with negative 2 to 2. And then for the y, go from negative 1 to 1 because I need to be able to see where 0 is. And so the graph comes in from the left equals 0. And from the right equals 0, so that seems like I got that one right. Then for example number 2, the limit as x goes to infinity. And here we'll have the natural log of x and e to the x divided by e to the x. So if you substitute infinity in for this x right here, the natural log of infinity is infinity. And e to the infinity is also infinity. So these are the two cases when you could use L'Hôpital's rule. If it's 0 divided by 0 or infinity divided by infinity. And then you just do the same thing. Write down a little L apostrophe H for L'Hôpital's rule. And it's still going to say the limit as x approaches infinity. And then the derivative on the top will be 1 over x. And now the derivative of e to the x is e to the x. Now with this one, I could do a little bit of algebra to simplify it because right now this is a complex fraction. So what I'll do is multiply by x to get that to cancel out, but then I'll need to multiply by x. So then this one is going to equal the limit as x approaches infinity. On top there's just a 1, and on bottom there's an x times e to the x. Now, if x is going to infinity, this is going to be infinity times this is infinity, which means this is going to 1 divided by infinity. And if you have one object, one pencil or one pen, and you divide it into an infinite number of pieces, the size of each piece is so small, it counts as 0. So then take a look at the graph for that one. So it is the natural log of x. Let me clear out this other stuff. And that gets divided by e to the x. And then this time we need the window to go out close to when x becomes an infinity. So how about 50? That's pretty close to infinity. And so you could see the function right here makes a little jump up, but after that it's basically right on the x-axis, which means that it's practically 0. And in fact, right there, the calculator's even rounded it to 0. So it seems like we got 2 in a row that are correct. For example, number 3. What's the limit as x approaches infinity? And this one's going to be 2 to the x over x squared. So to begin with, if x is going to infinity, 2 raised to the infinity equals infinity. On the bottom, infinity squared is infinity. So like I said, these are the two forms that it works for. This one is it's called indeterminate form. And so that means we can use L'Hopital's rule. So it's still going to be the limit as x approaches infinity. On the top, take the derivative of 2 to the x. And that is 2 to the x, and then times the natural log of 2. On the bottom, its derivative is 2x. Then, if x is going to infinity, this will be 2 times infinity, which is infinity. This will be 2 raised to the infinity, which is infinity. Which means that we get to use L'Hopital's rule a second time. So sometimes you get to use it 2 or even 3 times in one problem. It's pretty cool. So this will now be the limit as x goes to infinity. On the top, it's going to be 2 to the x, because the derivative of 2 to the x is 2 to the x. And then we would have to multiply by another natural log of 2. So you could either write it down twice or say that one is squared. And then on the bottom, the derivative of 2x is just a 2. And then we're pretty much done. Because if x is going to infinity, this is going to be 2 to the infinity. So that means that the top is infinity. The bottom is 2. And believe it or not, if you take infinity and cut it in half, it's still infinity. All right, then on to some that may require a little more work. So for example number 4, what's the limit as x goes to infinity of x raised to the 1 over x? So if this little x right here is becoming infinity, that means this is 1 divided by infinity, which becomes 0. So this exponent is becoming very, very small, while at the same time the base is getting very big. Well, let me just show you numerically what that's saying. So if you have like a 10 and then you're raising it to the 1/10th power, so that means you're taking the 10th root of 10 equals 1.259. And then if it's 100, and then you're taking the 100th root of 100, a 1.047. So it did actually get smaller, which then tells me the answer is probably not going to be infinity. Now with this one, so you need to verify that it's either of this form, 0 divided by 0, or it's infinity divided by infinity. The problem with this is these two are not being divided. One's an exponent and one's a base. So here's what you got to do that's a little bit different. So you start with, say that y is equal to this function. Then what we could do is take natural log of both sides. That was sloppy. The natural log of y equals the natural log of x to the 1 over x. And then on the right side, use the rule that says this exponent, you could bring it in front and multiply. And because this is a fraction, I can rewrite the right side as the natural log of x over x. Now I have something that is one thing divided by another thing. So now take the limit as x goes to infinity for this whole thing. And the left side doesn't have an x in it, so I'm just going to leave that there. But the right side does. And if you take the infinity and substitute it in, this on the right side is going to be, on the right side, it's going to be infinity divided by infinity. So that means that over here on the right side, we can use L'Hopital's rule. The left side, it's still going to say ln of y. So then I'm using L'Hopital's rule on this step. And for the numerator, the derivative of the natural log of x, that's going to be 1 over x. And on the bottom, the derivative is 1. Now keep in mind it's still the limit as x is going to infinity. And so this part right here is going to become 1 divided by infinity, and 1 divided by infinity is equal to 0. So we've got this part, and then this becomes a 0. 1 divided by infinity is 0. And the last thing we need to do is solve for y, so then exponentiate each side. And it turns out y, which was the original problem, is equal to e to the 0, which equals 1. And so my conclusion, therefore, the limit as x goes to infinity for x raised to the 1 over x, that equals 1. Now, if you go back to when I was doing those numerical examples at the beginning, this was a 1.2, then a 1.047, and then if you take 1,000 raised to the 1 divided by 1,000, these answers are getting closer and closer to 1. So me getting 1 for an answer seems correct. So this is with 10,000. So the answers are getting closer and closer to 1. So I believe that this one is true. And then one more example. How about infinity versus 0? Who's going to win? Infinity times 0 equals what? And when you're talking about limits, the answer could be anything. It could be that 0 wins and the answer is 0. Could be that infinity wins and the answer is infinity. Or it could be that 17 shows up and wins the whole thing. So for example, number 5. So how about the limit as x goes to infinity of a 17x squared, and then that gets multiplied with 1 over x squared plus x. So if x is going to infinity, this part will be infinity. This will be 1 divided by infinity, so that means essentially we have infinity times 0. Now with this times right here, we can't really do L'Hopital's rule. It has to be divided. So then it's going to be 17x squared over x squared plus x. And then we could do L'Hopital's rule. And when you take the derivative on the top, that's going to be 34x. When you take the derivative on the bottom, that'll be 2x plus 1. And this will be infinity over infinity, so that means use L'Hopital's rule a second time. Thus denoted in red. The derivative on the top is going to be a 34. The derivative on the bottom is going to be a 2. And believe it or not, 34 divided by 2 equals 17. So even though the problem started off with a 0 times infinity, turns out the answer is 17. So my point with this one is just because you see a times 0, people will automatically say, oh, that equals 0. No, not when you're talking about limits. It could equal 0, it could equal actually anything. So that's it. Until next time.